So, good afternoon.
Good afternoon,
Good
sir.
afternoon.
Good afternoon, sir.
Okay. Yesterday we seen about bioassay, how to conduct an experiment to measure the response a pesticide produce in an insect. എന്താടോ ശ്രീശ എന്താ പറഞ്ഞേ? Okay. So yesterday we had seen about methods of bioassay, and today's class will be an extremely short class because a major part of this class is taken up as a practical. As we can't take up that in an online mode, I am leaving it to a period when we can conduct that practicals. Okay. So this is with respect to Probit analysis, wherein we can derive the data from the which we got from bioassay, and it can be used to measure various parameters such as LD50, LC50, LT50, KD50, KC50, whatever it may be. So today I will just discuss about the basic fundamental aspects of probit analysis. Why probit analysis has been is a method which is used to measure the efficacy of a pesticide. Uh, Most of you have written the brief on the probit analysis perfectly. So this is just a reminder of what you have written. So here, whenever we are carrying out analysis of variance or ANOVA, you might have studied about transformation of data. Have you studied about transformation of data? Yes. What are the kinds of transformation? Angular, logarithmic, square root. Okay. We have several kinds of transformation. In the same manner, probit analysis is also kind of analysis wherein we are transforming the data so that the data can be analyzed as a regression analysis. Probit analysis is nothing but a regression analysis. But before taking up that regression analysis, we will convert our data, or we will transform our data so that the data can be subjected to regression analysis. And here, whatever data we get for by bioassay, if we carry out bioassay, we normally get our data in a binomial form. That means if we have kept say 10 insects and carried out a bioassay with a particular dose, and we got 6 insects as dead, then remaining 4 are live. So we have only two options, either dead or live. We don't have a partially dead, partially live, or anything like that. We have only two options, that is either dead or live. So binomial response means it is having only two options, dead or live, yes or no. So if our data is having these kind of response variable, we can go for regression analysis. But the problem with the regression analysis of our bioassay data is that if you see the bioassay data, see this graph. Here, the x-axis is the dose, the y-axis is the percentage of insects. That means the quantity of number of insects died, the percentage of insects died with at each dose. See, the graph, it is moving like this, almost like a sigmoid curve. So, if you have studied about regression analysis data should be linear, just like this. It should be like this. It can't, if we have data like this, we cannot analyze it by regression analysis. So that is one particular drawback with our mortality data. So one thing is that we can go for converting our dose data into log dose. So we earlier it was dose alone. Here we have converted the dose into logarithmic values, into the logarithmic values. Even then, the data remains a sigmoid, a typical sigmoid curve. Here, one thing you should remember, see, this is a sigmoid curve, a shaped curve. You might have seen this in the, studied this in the case of several theories, several classes and all, economics and all, you might have studied it. So here, one thing you can see that, see, from over here, see, this is 20 and this is somewhere in the case 90. See this region of the graph. Here, the change in concentration, if I draw it over here to mid x-axis, see, it is varies from roughly from 0.8 to 1.1. And if within this dose range, the response, the change in mortality is extremely sharp. But see this, between 0 and zero point 0.8 there is a variation of 0.8, but even then the change in mortality is from 0 to 20 only. But see the change in dose from say 0.8 to 1.1, that is a mere change of 0.3. With that the mortality changes from 20 to 90. That means the response of any organism to a particular toxicant is greatest between this range 20 and 80%. Below 20 percentage and above 80 percentage, the response will be extremely slow. Here you can see the graph lifts up very slowly, but once it reaches 20, it shoots up. But once it crosses 90, again it slows up. So the response is maximum between 20 and 80. And here comes the 50% mortality. And if you see this, this is the area where the response is maximum. That's why we take LC50 as the dose which we can compare, which we can use for further analysis, because that is the dose at which the response of an organism will be maximum. Or in other way, we can say that with a slight change in dose, there will be a great change in response in this area. So that's why we take LC50 for our analysis. So it transfers sigmoid dose response curve to a straight line so that data can be analyzed by regression. As most of you have written in your write-up, it was first proposed by Bliss and later developed by Finney. We have a book written by Finney as the name of Probit analysis itself. So when you come over to college back, I will show you that. Okay, see it over here how a sigmoid curve is converted to a straight line. See, this is a sigmoid curve where we have not converted the mortality data, but we have transformed the mortality data into Probit so that it becomes linear, so that it can be analyzed by regression analysis. So this is what we call it as Probit analysis, the base or fundamental of Probit analysis. One thing, one basic assumption is that the dose response relationship is normal. That means you might have studied about normal distribution and all. I have studied normal distribution. I have studied the bell-shaped curve in a normal distribution. Yes or no? Yes. I think that bell-shaped normal distribution curve is familiar to you. So here also what I told is exactly visible in this graph. See, this is the standard deviation. See, this is the frequency. How much number of organism, how many number of organisms responds in this range. See, the maximum response is in this position, that is in the 50% position. That is why we take LC50. See, this one again, the maximum, the frequency, the maximum response will be in the 50 at 50%. See here, you can see 0.15 to, that is standard deviation. See this 50, this is at 0. So the maximum response or the maximum number of organisms that respond to the particular pesticide will be at that LC50. That's why we take LC50 as the criteria for various analysis. So this is one thing, the basic assumption, we assume that the dose as well as response, or we can say that the dose mortality relationship, because we normally talk about mortality of caused by insecticide. The dose mortality relationship is normal or have a bell-shaped curve. So what we will do is we will convert the mortality between 0.01 to 99.99 into units of normal deviation called as probits. I will we have Finne has given a table wherein we can convert the mortality, person mortality data into Probit. Whenever we are doing our practicals, I will show you how to convert, how to transform our person. It not we are not converting the true mortality data. In the first experiment, first example, I told you that we took 10 insects, 6 died and 4 are alive. So that means we have 6 insects dead. So we won't take, we don't transform 6 into probit. We take the percentage of it. If we take the percentage, it is 60. This 60% mortality is converted into probit. So the person mortality will be converted into probit. Finney has given a table for that we will discuss when we do the practicals. And the probit ranges from 0 to 50. So the range of probit will be from 0 to 50. If you take the, I will show, okay. This is the probit. It is depicted from 3 to 7.5, but it varied. The minimum is 0 and the maximum is 10. It can't go below 0 and it can't go above 10. And probit 5, the value of 5 corresponds to LC50. So I will show it over here. So this one, if you want to calculate the LC50 of this, so it will be over here. So if you draw it over here, you will get the log dose. Take the anti-log of this dose, you will get the LC50. You will do it in the practicals, how we will do it. So the mortality, the person mortality data, we will convert it into units of normal deviation called as probits, and the value of 5 in probit corresponds to LC50 or LD50. And I am not going into the methodology and all because we have to do it practically. So this I have given only as a short introduction on probit analysis, because this usually I take in along with the practicals, and after this broad introduction I will use to take up the practical, so that the entire thing, how we transform and how step by step how we go about the calculation of LD50, that is normally taken up in the practical class. Let's see how we can whether we can complete it in the classroom session. If the corona does not permit us to do that, then we will do it online. Again, we will do it online. Okay. Nowadays the thing is that we have softwares wherein we can calculate wherein we will be able to calculate LC50 by softwares, even the normal statistical softwares such as SPSS, even Excel can calculate LC50. So this is because this is nothing but a regression analysis. Only thing is that we have to convert the data into person mortality, then the person mortality into Probit. So this is an extremely short class. This is just giving a brief. So any doubts about it? No? Okay. So what about your next week? I will start this one insecticide resistance. Go through the material and write a brief on it. I will take class only on Monday, so you have 3 days. So go through it and have an understanding of what is insecticide resistance. Okay. Anything else? ആർക്കും ഒന്നും പറയാനില്ലേ? ശ്രീലക്ഷ്മി, ആ എന്താടോ,
Sir,
ഒന്നും പറയാനൊന്നുമില്ലേ?